warahmatullahi wabarakatuh. In this video, we will present the topic of friction welding. First of all, our group consists of 4 members, namely me, Nur FATIHAH binti NORDIN, next Shakir Zufayri bin Shahrum Zamir, AZLAN bin SAMSUDIN, and lastly Nur ALIA NATASYA binti ARIF. Now I will explain the abstract. Friction welding is a well-established commercial procedure for joining polymers and metals or alloys that are close but not identical. The number of applications for the friction welding process have been emphasized in many sectors during the last 20 years, but relatively few contributions have been published relating the properties of friction welded joints of incompatible polymer or plastic material following reinforcing with metal powder. In this PowerPoint, we will go over the introduction of friction welding as well as a literature review, application and working principle, which is performance advantage and limitation. Welding is one of the most frequently used joining techniques, with both classic and non-traditional process used in almost every industry. Solid-state welding, fusion welding, and solid-liquid welding are the 3 basic types of welding mechanisms. In this slide, I will explain about introduction of friction welding. Friction welding is a type of solid-state welding method in which heat is generated by mechanical friction between a moving workpiece and a stationary component, with the addition of a lateral force called upset to plastically displace and fuse the material. Friction welding is a forging technique rather than a welding procedure in the classic sense.
The first literature review from this is a review of experimental investigation in friction welding technique written by Guru Nak Shindi and Prakash Daber. From this research, we can see the parameter for the experimental they made, with its first one is aluminum and magnesium alloy, with its having 101 megapascal when friction time at 5 seconds. The joints are brittle, the fracture is almost flat surface. Next is aluminum and austenitic stainless steel, with its 150 megapascal at 573 Kelvin when joined, no crack, high joint efficiency, and 90% bend ductility. Next, we can see titanium alloy and stainless steel, with its speed is from 400 to 1800 RPM. Joint strength are at 468 megapascal and joint efficiency of 90%. Next is magnesium and titanium, with its depth hardness gradient from titanium to magnesium, form a continuous intermetallic layer with magnesium and titanium. From critical analysis, the formation process are mapped.
The second part for literature review is what is friction welding, principle and types of friction welding by Anup Kumar Deyi. In this slide, I will present steps in friction welding. Step 1. One part to be welded is placed in a rotor driven chuck and the other part is held stationary. Now the rotor is switched on to rotate at very high speed along with the workpiece. Step 2. The rubbing of welding surface creates sufficient heat of the order of 900 until 30,000 Celsius for steel. Now a high pressure is applied through the stationary part. Step 3. Once the temperature of the welding surface reaches to the required temperature, the rotor is stopped. Step 4. Now the pressure is increased continuously till both the parts weld to each other.
The third literature review is from 3 Friction Welding MFT, written by Ramu Amara. In this research, we can see they tell us about two other type of friction welding. With its first continuous in this friction welding, with its rotor connected with a bend brake. Rotor stop when comes to limit plastic temperature. Pressure will increasingly apply until wet is formed. second one is inertial friction welding. Flywheel connect chucks to the motor from the start. The engine flywheel will separate from shaft when friction reach limit. The flywheel will stop without brake. Force will continuously apply until the weld forms. The last part for the literature review is from Friction Welding, Everything You Need to Know by Pierce Industry. There are four. In this research, they tell us there are four types of friction welding, which is the first one, direct drive friction welding, which is this type spindle drive motor attached to spindle shaft permanently and rotate. Spindle will slowly and welding are processing the spindle stop at predetermined point. Second one is linear friction welding. Chuck is oscillated in lateral motion. Only workpieces that have high shear strength can join part of any shape. The third one is friction stir welding. FSW, which is solid state joining process using non-consumable tools. Soften the material of two-piece metal used in modern shipbuilding, train, and aerospace. The last one is orbital friction welding, which is both welded parts are rotated at the same direction and speed at axis offset up to 1/8. Rotation is slow and retained to same axis, while fogging is maintained when weld complete.
Okay, next is application for friction welding. First, it is used in electrical industries for welding copper and aluminium equipment. Second, friction welding can be used to build better industrial roller, tubes, and shaft. Third, friction welding is used in automotive parts like engine valve and shock absorber. Fourth, hydraulic piston rod and thread roller in agricultural equipment are also joined by friction welding. And next, friction welded assembly are often used to replace expensive casting and fogging. And lastly, gear, axle tube, valve, driveline are also welded using friction welding. The next is the effect of parameter involved. So first, for friction time, from the research, we can say that the increasing friction time will increase the tensile strength of the joint. The type of intermetallic compound was variable with increasing friction time, which means a longer friction time can cause the excess formation of an intermetallic layer. However, some of the welds show poor strength depending on some accumulation of alloying element at the interface. Second is friction pressure. So we can say that when the friction pressure increase, the thickness of intermetallic compound layer at the interface decrease as a result of more mass discard from the welding interface. The heavy thickness of intermetallic compound layer seriously can worsen the mechanical properties of the joint. So, the formation of microcrack could be controlled effectively under this higher friction pressure. Third is upset time. So, the strength of the joint varied with increasing upset pressure and upset time, which means the joint strength increase and then gradually decrease after reaching a maximum value with increasing upset pressure and upset time. The joint strength depended on the size and shape of the tensile test pieces. So, the longer upset time causes the formation of an intermetallic reaction layer at the weld interface, and the reaction layer grows as the upset time increases. Okay, next is upset pressure. It was stated that when the upset pressure increase, the tensile strength of joint also increase. So we can say that as upset pressure decrease, the toughness also decrease. So next is burn-off length. So the quality and the strength of the bond produced are also vary, which means the higher the burn-off length with low upset pressure, decrease in impact toughness of the friction welded joint, whereas with low burn-off and high upset pressure will result in increase in toughness of welded joint. Furthermore, the shrinkage of the specimen also increase when the burn-off length increase. So next is rotational speed. So the experimental result show that a higher speed had a significant effect on the structure of the joint, and also it had improved the micro hardness and bending strength. It was found that the fracture proceed mainly through the cleavage plane at a low speed, while the fracture was occur through the dimple at a high speed. So the joint strength increases and then decreases after reaching a maximum value with increasing rotating speed. So we can conclude that the tensile strength and impact toughness increases with the increases in rotational speed and decreases constantly.
Now we will talking about frictional welding durability. Frictional welding not only turns out strong welds, it also turns out welds that remain strong. This is especially crucial in the kinds of high-performance environments that friction weld components are subjected to in post-production operation. The durability of the friction welding is one of the reasons it is so prevalent in marine, air, and space industries. Friction welding also produces strong, consistent joints by utilizing tubes, bars, and plates. It allows you to design complex parts that may otherwise be cost prohibitive to create. A large diameter cylinder rod could take 20 to 30 minutes to weld using the standard way. With friction welding, this could be 5 to 7 minutes weld. Faster cycle time means more part welded in less time. This is definitely saving the cost. Okay, now we will discuss about the advantage of friction welding. So the first advantage is it is environment friendly process without generating smoke. Second advantage is narrow heat affected zone, so no change in properties of heat sensitive material. Third advantage is no filler metal required. Fourth is welding strength is strong in most cases. Fifth is easily automate. Sixth is high welding speed, and last but not least, high efficiency of weld. And lastly, wide variety of metal can be welded by this process. Okay, now we will talk about disadvantage of the friction welding. The first disadvantage is this is mostly used only for round bars of same cross section. Secondly is non-forgivable material cannot be welded. Thirdly is preparation of workpiece is more critical. Fourth is high setup cost. Fifth is joint design is limited.